All right, this is lesson 3.2. The focus is parallel lines and transversals. We're going to introduce a couple of theorems. The first theorem is theorem 3.1, called the corresponding angles theorem. It says this: if two parallel lines are cut by a transversal, then the pair of corresponding angles are congruent. And theorem 3.2, the alternate interior angles theorem. If two parallel lines are cut by a transversal, then the alternate interior angles are also congruent. And then theorem 3.3, the alternate exterior angles theorem. If two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. And lastly, theorem 3.4, the consecutive interior angles theorem. If two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. Now note, these are theorems, so they must be proven. But let's take a look at example 1. The measures of the three of the numbered angles are 120 degrees. Identify which ones. Explain. So we know a couple of things. We know that corresponding angles are congruent according to our theorem. So first thing we ask ourselves is which angle is in the same position as 120 degrees in the second pair. So we can see that 5 sits in the same position. So we know that angle 5 is also 120 degrees. Now, our theorems also say that alternate interior angles are congruent. So we know 5 is alternate interior to angle 4. So angle 4 is also 120 degrees. And lastly, we know that alternate exterior angles are congruent. And we know that 120 degrees and angle 8 are alternate exterior. So angle 8 is 120 degrees. So angle 8 by alternate exterior angle theorem is 120, and 5 and 8 we could use vertical angle congruence, or we can use the other parts I said before, corresponding or alternate interior. So the measure of angle 8 is 120 degrees by alternate exterior angle theorem, and since angles 5 and angle 8 are vertical, these are congruent. And since 5 and 4 are alternate interior, these are congruent, and it's also 120 degrees. All right, the numbered angles that measure 120 degrees are thus angle 4, 5, and 8. All right, your turn. Give it a try. The measure of angle 1 is 104 degrees. Find the measure of angle 4, the measure of angle 5, and the measure of angle 8. Tell which theorem you use in each case. Pause the video and give it a try. Example 2. Find the value of x. All right, we see two parallel lines. A and B are parallel, and we can see they are because the parallel marking. Thus, we know a couple of things. We know that 115 and 4, those are vertical. And we know that vertical angles are congruent. So we know that angle 4 is 115 degrees. Now, we know these two angles here, angles 4 and x plus 5 degrees, are what we call consecutive interior. And according to our theorem, consecutive interior angles are supplementary. So we know vertical angle congruence, 4 is 115. And by consecutive interior angle theorem, the measure of angle 4 and x plus 5 are supplementary. We know supplementary means adds to 180. So we know that the measure of angle 4 plus x plus 5 is 180 degrees. We know that angle 4 is 115. So we have 115 degrees plus x plus 5 is 180. Combining like terms, we see 115 plus 5 is 120. We would like to solve for x, so we'll subtract 120 degrees. And we get that x is 60 degrees. All right, example 3. Find the value of x. Okay, so first off, we can see that this angle here and this angle here, angle 1, form a linear pair. Thus, those two angles are supplementary. By linear pair postulate, we can find that angle 1 is 180 degrees minus 136. Thus, angle 1 is 44 degrees. Now we know that angle 1 and this angle here are alternate exterior angles, and thus are congruent. So we know they equal the same thing. We know that angle 1 is 44 degrees. So 44 degrees is equal to 7x plus 9 degrees. We'd like to solve for 7x, ultimately for x, so we're going to subtract 9 from both sides, and we get 35 is equal to 7x. To get x by itself, we divide both sides by 7, and 35 divided by 7 is 5 degrees. Now it's your turn to try. Given that the measure of angle 3 is 68 degrees, and the measure of angle 8 is 2x plus 8, what is the value of x? Show your steps. Pause the video and give it a try. Check in with Ms. Curtis when you think you have it. All right, example 4. Prove that if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. Let's start with this image. Lines P and Q are parallel. We would like to prove that angles 1 and angle 2 are congruent. Let's start with the given. P is parallel to Q. Then let's take a look at what we know. We know that angles 1 and 3 are corresponding, and that corresponding angles are congruent by the corresponding angles theorem. We know that angles 3 and 2 are congruent by vertical angle congruence. Now, if 1 is congruent to 3 and 3 is congruent to 2, then we know that these link together and that 1 is congruent to 2 by the transitive property of congruence, and thus alternate interior angles are congruent. Example 5. When the sunlight enters a drop of rain, different colors of light leave the drop at different angles, thus forming a rainbow. This process is what makes the rainbow. For violet light, the measure of angle 2 is 40 degrees. What is the measure of angle 1? Well, looking at the image, we can see that angles 2 and angle 1 are what we call alternate interior angles. We know that alternate interior angles are congruent. So, because they form alternate interior angles, we know that angle 1 is congruent to angle 2, and thus angle 1 is 40 degrees. Now it's your turn. What if in example 5, the yellow light leaves a drop at an angle of 41 degrees? What is the measure of angle 1? How do you know? Pause the video, give it a try. All right, be sure to check in with Ms. Curtis. This is the end of the lesson, and then go ahead and grab the next practice assignment. Once you finish that, you're done.